Hello everyone. Today is 14th March, and today is a Pi Day. So it's very important day for all the mathematicians out there and those who love mathematics. So I have today Indian Express page, explained page. So there are few important articles that froth in small stocks and why regulators are worried. So yesterday the bubble that was there in the Sensex, it burst, and many small and mid cap shares were down by several percentage points. So that is an important article to know. But another important article is about FBR and energy security. So this is about Kalpakkam fast breeder reactor. So FBR. So we'll read this article. So what it says that first I will read what is given in the box. So nuclear fuels and reactors. So nuclear fuels are classified as fissile U-20, 233, U-235, and plutonium 239, or fertile U-238, thorium 232. Fissile isotopes can be directly used as nuclear fuel. Fertile isotopes need to be converted into fissile before they can be used. So U-235 is the only fissile isotope that occurs in nature. Okay, so that is a good thing to know. In India, the resources of exploitable uranium, natural uranium is mostly U-238 with only 0.7% U-235 are limited, while thorium 232 is abundantly available. I think world's one fourth of the thorium reserves is with India. So both fissile and fertile isotopes are precious commodities that must be used judiciously for optimum utilization. So pressurized heavy water reactors which burn U-235 also convert fertile U-238 to plutonium 239. So this plutonium is used in fast breeder reactors as a fuel to generate electricity, and plutonium 239 is also used to making nuclear bombs. So fast reactors produce more fuel than they consume. They also aid in the conversion of fertile thorium 232 into fissile 233, which can be used to fuel subsequent reactors. So that is important to learn. So India's three-stage program. Stage one, pressurized heavy water reactors are natural uranium-based fuels to generate electricity while producing fissile plutonium 239, which can be extracted by reprocessing the spent fuel. Okay. Stage 2, fast breeder reactors of the kind at Kalkappam using PU, plutonium based fuels, can enhance nuclear power capacity and convert fertile thorium into fissile uranium 233. Reprocessing of the spent fuel is vital for efficient utilization of plutonium inventory. So, what is stage 3? U-233 produced in the second stage can be used for the third stage of the power program, which consists of advanced thermal and fast breeder reactors. For long-term energy security, in addition, fissile isotopes can be produced by a accelerator driver driven subcritical reactor system. So conversion of fertile isotopes into fissile isotope is known as actually uranium enrichment. So let us read this article. The vital second stage of India's three-stage nuclear program got a boost with the commencement of core loading of the country's first indigenous fast breeder reactor at Kalpakkam, Tamil Nadu earlier this month. Core loading refers to the process of placing nuclear fuel assemblies inside the core of a nuclear reactor. The initiation of the process was witnessed by Prime Minister Narendra Modi on March 4th. The completion of core loading will effectively mark the first approach to criticality, the initiation of self-sustaining nuclear fission reaction that will eventually lead to generation of power by the 500 megawatt electric FBR fast breeder reactor. So India's FBR program. So efforts to build an FBR were initiated 2 decades ago, and successive governments have nurtured the project as a step towards India developing comprehensive capabilities that span the entire nuclear fuel cycle, by which electricity is produced from uranium in nuclear power reactors. In 2003, when Atal Bihari Vajpayee was Prime Minister, Bharatiya Navikiya Vidyut Nigam Limited, or Bhavini, was incorporated to build and operate India's most advanced nuclear reactor, the prototype fast breeder reactor. The project was expected to be completed by September 2010 but was delayed due to technical challenges. The last set of approvals had revised the completion target to October 2022. So, once commissioned, India will be the second country after Russia to have a commercial operating fast breeder reactor. China has a small program on fast breeders, Programs in countries such as Japan, France, and United States were shut down amid safety concerns. From fertile to fissile. Okay, so the Department of Atomic Energy three-stage power program envisages a pathway to utilizing India's abundant thorium reserves found in coastal and inland placer sands on the beaches of Kerala, Tamil Nadu, Odisha, Andhra Pradesh, Maharashtra, and Gujarat, and inland riverine sands of Jharkhand and West Bengal to generate electricity. A placer deposit is a natural concentration of heavier minerals created by the action of gravity on moving particles. These concentrations are typically found along streams, rivers, beaches, and stretches of residual gravel where they wash up. Besides thorium from monazite ore, gold, platinum, titanium, uranium, and rare earth elements are commercially mined from placer deposits. India owes the vision of the three-phase program of the nuclear power to ensure energy security to Dr. Homi J. Bhabha, the father of India's nuclear program, and Dr. Vikram Sarabhai, who recognized the need for developing fast breeder reactors. As these reactors generate more nuclear fuel than they consume due to the gainful conversion of fertile isotopes into fissile material, the three stages involve the conversion of fertile material which is not fissionable by thermal neutrons, but can be converted into fissile material. For example, U-238, the dominant isotope of uranium, is a fertile material that cannot by itself make the reactive reactor achieve criticality and has to be converted to fissile plutonium 239 in a nuclear reactor. The spent fuel from the thermal reactor contains plutonium 239, which is most efficiently burned in a fast reactor. Thorium, being monazite 2, is a fertile material that has to be converted into fissile material U-233. India has adopted a closed fuel cycle approach, which involves the reprocessing of spent fuel to separate the useful plutonium 239 and U-233 isotopes from U-238 and thorium 232 to multiply the fissile inventory and to gradually work towards establishing a higher power base. It is a key to ultimately use thorium in the third stage of the program. The fast breeder reactor is an important milestone for getting to the third stage, paving the way for the eventual fall utilization of the country's thorium. Three stages and fast breeder reactor. The first stage, the setting up of pressurized heavy water reactors and associated fuel cycle facilities, is in progress. Pressurized heavy water reactors are reactors that use natural uranium as a fuel and heavy water deuterium oxide as a coolant and moderator. Okay, so pressurized heavy water reactors use natural uranium as fuel and heavy water as coolant and moderator. Okay, so this is important to know. Nuclear Power Corporation of India Limited operates 22 commercial reactors with an installed capacity of 6,780 megawatt electric MWE. The program has been supplemented by construction of imported light water reactors. The first of two units built with Russian collaboration is already generating power. The second stage involves the setting up of fast breeder reactors backed by reprocessing plants and plutonium fabrication plants, primarily to multiply the inventory of fissile material. The multiplication of fissile inventory is also needed to establish a higher power base for using thorium in the third stage of the program. The third stage will be based on the thorium U-233 cycle for producing U-233 obtained by irradiation of thorium in pressurized heavy water reactors and fast breeder reactors as an advanced heavy water reactor is proposed. The combination of power reactors from all the three stages is expected to ensure long term energy security for the country. But the commercial utilization of thorium on a significant scale can begin only when abundant supplies of either 233 or plutonium 239 are available. The progress of the fast breeder reactor has made the passage to the third phase visible. So, what are the way forward hereafter? As core loading commences, the fast breeder reactor will initially use uranium plutonium mixed oxide fuel, officials said. The U-233 blanket around the fuel core will undergo nuclear transmutation to produce more fuel, thus, the name breeder. The nuclear transmutation involves the conversion of a chemical element or isotope into another chemical element with the number of protons or neutrons in the nucleus of the atom undergoing a change. The use of thorium 232, which is not fissile material, as a blanket is also envisaged in this stage. Through transmutation, thorium will create fissile 2U233, which will be used as a fuel in the third stage. The Department of Atomic Energy maintains that despite the use of this advanced technology, both the capital cost and per unit electricity cost are comparable to other nuclear and conventional power plants. While the first of the three stages, is already underway with the pressurized heavy water reactor program, the India US civil nuclear deal has opened the door for India to buy uranium for its domestic reactors, thus increasing the pace of the nuclear program. The Department of Atomic Energy aims to increase the share of nuclear power in the country in the energy mix by 2032 by producing 22,400 megawatt electric from its nuclear power plants. It has approved the construction of 10 new pressurized heavy water reactors in fleet mode, in which a plant is expected to build in 5 years from the first pouring of concrete. Okay, so this was about the fast breeder reactor and India's energy security, the nuclear power plants. So another important article, I found it interesting, that pi day. So understanding the most famous mathematical constant. So March 14 or 3 by 14, it can be written as the pi's value start from 3.14. So as per the American convention, is celebrated as Pi Day worldwide as an ode to the most well-known approximation 3.14 of the mathematical constant pi. The tradition was started by physicist Larry Shaw on the Exploratorium Museum in San Francisco in 1988 and has since seen global popularity. On the day, mathematicians try to raise awareness on their subject among lay persons through lectures, museums, exhibitions, and pie eating competitions. In 2019, UNESCO's 40th General Conference designated Pi Day as International Day of Mathematics. Okay, so National Day of Mathematics is celebrated on 22nd December on the birth anniversary of Srinivas Ramanujan, and International Day of Mathematics is today, 14th March. So, what is pi? Pi, often represented by the Greek letter pi, is the most famous of all mathematical constants. It represents the ratio of a circle's circumference to its diameter. A straight line between 2 points, obviously, we know. Regardless of the circle's size, the ratio always remains constant. So pi is an irrational number. It is a decimal with no and no repeating pattern, which is most approximated to 3.14 or the fraction 22 by 7. So how is pi calculated? The importance of pi has been recognized for at least 4,000 years. Academic Petra Beckmann, in his classic A History of Pi 1970, wrote that by 2000 BC, man had grasped the significance of the constant that is today denoted by pi, and that they had found a rough approximation of its value. Both ancient Babylonians and ancient Egyptians came up with their own measurements, probably by drawing circle of some diameter and then measuring its circumference using a rope of set diameter by it in length. Babylonians settled at 25 by 8, that is 3.125, as the value of pi, while ancient Egyptians settled at 16 by 9 to approximately 3.16. It was Greek polymath Archimedes in 287 BC who came up with the method to calculate pi that remained in use till the 17th century. He realized that the perimeter of a regular polygon of n sides inscribed in a circle is smaller than the circumference of the circle, whereas the perimeter of a similar polygon circumscribed about the circle is greater than its circumference. This can be used to calculate the limits within which the value of pi must lie. Now, as one keeps adding more and more sides to this polygon, it gets closer to and closer to the shape of circle. This is good. This is very right, and tends to infinity. Having reached 96 sided polygons, Archimedes proved that 2223 by 71, that is, or 22 by 7 in decimal notation. So somewhere pi value will lie between 223 by 71 and 22 by 7. So today we take approximately 22 by 7. Following Archimedes, this method was used by mathematicians, constantly increasing the number of sides of the polygon to calculate pi to ever greater decimal places. The problem with this method, however, is that it is extremely labor intensive. For instance, it took Dutch mathematician Ludolf van Sulin a staggering 3 decades to calculate pi to 35 decimal points. Okay, it would be Isaac Newton who significantly simplified the process calculating pi. In 1666, he calculated pi up to 16 decimal places using calculus, which he discovered along with the mathematician Gottfried Wilhelm Leibniz. What had taken mathematicians years to calculate now could be done in a matter of days. But why does it all this matter? Circles are everywhere in the world, so the all the dimensional shapes like cylinders, spheres, and cones, all of which carry the proportion of pi. Knowing pi's value thus has some crucial parameters benefits in the field of architecture, design, and engineering. From constructing water storage tanks to fashioning high tech equipment of satellites, the value of pi is indispensable in all sorts of areas. Moreover, pi seems to be woven into the description of the deepest workings of the universe, from calculating the vastness of space or understanding the spiral of DNA. So these were two important articles that I found on the explained page. Another important article was about AI, the first autonomous AI software engineer, who is whose name is Devin. So if a question is asked that what is Devin recently in news, so it is first autonomous artificial intelligence software engineer. So that is all from today. So we'll meet tomorrow.